I wanted to ask about the incoherent radar, the high resolution imaging that you showed us. Was that all performed based on the envelope of the returns?
For the asteroids and things like that. Yes, the target is quite deep, and so although you send a long pulse, you look at the shape of the envelope that returns, and then that's convolved with the other dimension of the target, and so it's a difficult inversion problem. But yeah, it's based predominantly on the shape of the return and also on the Doppler shift. Because if you've got a spinning object, one side is Doppler shifted towards you and the other side is Doppler shifted away from you. So you have quite a lot of information, but it is a difficult inversion problem to work out exactly what thing is out there that's causing that. And particularly if you're trying to do things which are really, really detailed, like if you're trying to map bits of the moon or other planets, this is big computing. But.
What kind of funny business is our government or other governments using Arecibo for now, or in the past, that has now been declassified?
I'm an alien. I wouldn't know. Come on. We're not currently doing anything classified that I'm aware of, and. So I'm being careful, but no, we're not doing anything classified. I don't know what maybe some of the early work was. I mean, it was the Cold War, and they were very interested in looking at what was going on in the vicinity of things like Sputnik that were going over, looking at the wake of spacecraft and so on. I believe that they did some observations of using the moon as a reflector. So by looking at what was reflecting off the moon, you could perhaps look at or listen to overhear communications, radio communications on the other side of the planet, so things like that. But nothing terribly exciting, I'm afraid.
Since movies have been so important in terms of advertising Arecibo, when a movie comes along, how long does it take, and how much scientific studies, or does it interrupt, or well, anyway, what happens when a movie is being made, and how long does it take?
Both the movies that I mentioned were made long before I had anything to do with Arecibo, but I've had some experience in doing things at other facilities, and it does take a long time, and they take over your entire life for significant lengths of time, and they don't take no for an answer to anything that they want you to do. But the impact's not that great. The telescope typically works round the clock all the time, so movie people sleep. So.
How do you discern a certain chemical by using the radar with the dish?
The incoherent scatter radar, the return signal has a very complicated spectral shape. So when I showed the image earlier on, you could see that it was a kind of a double-humped spectrum. And the width of the spectrum depends both on the temperature of the stuff that you're scattering from and also its mass. So a heavier atom will have a narrower spectrum. And so the echo that we get back is a combination of spectra that are generated by the different constituents of the atmosphere or of the target that you're looking at. And so again, it's an inversion problem that we have to work out how much of X plus how much of Y plus how much of the other would actually add up to give us the signal that we see. So we iterate the data until we can reproduce what we saw and then say, well, that must be what the combination of what was in the atmosphere that caused it. And because the signal from Arecibo is so good, and we have such real precision in the shape of the spectrum, it's really very good for that. We can do remarkable amounts.
Why didn't Jocelyn Bell get Nobel Prize?
Why didn't she? That's a good question. Next. Many people have asked that question. And said it was unfair that Hewish got it. The question was, why didn't Jocelyn Bell get the Nobel Prize, or indeed share in the Nobel Prize? The Nobel Prize went only to Tony Hewish, who was her supervisor. And I think many people have seen that as being a big injustice. I've heard Jocelyn Bell interviewed subsequently, and she's very philosophical about it, and kind of says, you know, well, he was the brains, he was the supervisor, and whatever. But the same thing applied to Hulse and Taylor. Hulse was the student and did the work, and they both got the Nobel Prize. So I don't know what was in the mind of the Nobel Committee, but I don't think anybody would have felt it unreasonable if they had awarded it jointly.
A couple of financial kind of questions. Where did
Yes, please bring me your checkbook.
Who paid for the initial construction of the facility?
It was the precursor of DARPA, so was it ARPA or whatever that existed then, so advanced projects. So, and then it was transferred to the National Science Foundation after 10 years or so, something like that.
And what organization actually owns it?
Today it's owned by the National Science Foundation, but operated by us under a cooperative support agreement.
And then one final question. How affected are you by weather? Wind, rain?
The operation of the facility in terms of the radio signal, really not much affected by the weather. As you go to higher frequencies, you begin to have trouble with the rain. But we are in a hurricane zone. And so actually when we're expecting hurricanes, we do batten everything down. And indeed we send people off the site just to be safe. So some effect, but not a huge effect.
More on the financial thing. We noticed one of your slides has a piece of gear from CSIRO. Do you have a whole lot of, what do you call them, partners, or do they rent the space? Or?
They don't rent the space, but we do support visiting instruments, and a lot of the instruments, a lot of the receivers there are developed by university groups or by consortia, and that Alpha Array was a consortium that prepared that. And so we host them and support them, and they bring their own equipment. And so it's quite normal to see new pieces of equipment being hoisted up into the Gregorian and brought down again. So.
And for us non-scientists, the origin of the term Gregorian, is that something to do with ancient music? Or?
You know, I don't know. I don't know why it's called a Gregorian feed. Next time I give this talk, I'll know the answer. Or at least Bob Kerr will.
This is a really interesting and valuable program, but it doesn't appear to be reaching young people. This is not a group of high school kids. It's not a group of college kids. Is there any effort to get to the young who need to know this?
There's a huge program going on in association with the Visitor Center in Puerto Rico. We're moving a lot of school children, aged children through the facility. We have a grant from the Department of Education in Puerto Rico to do that. We have a series of summer schools bringing in students and doing. We have summer undergraduate experience and research placement programs going on. We have a lot of PhD students passing through studying. I agree with you that we need more. I mean, we need more students in science in general. Arecibo ought to be a magnet.
Even a little flyer out to each of the high school science teachers would help.
Yes, we also have a program going on at Arecibo for teachers. And so we have a summer program for teachers there. So we're trying to teach teachers so that they spread the word. So we're trying.
Not hard enough.
So I came across this startup that's funded by Bill Gates, among others, and I want to say it's called Chimera, and they have this plan to use outer space satellites to provide ubiquitous telecommunications all over the planet, so you don't need to be near an access point. So it made me think, as you were talking today, it made me think about what are the commercial applications for this observatory, and are there any?
Mostly what we do is pure science, and it doesn't really have a very immediate commercial application. There is some commercial application, potential commercial application in the planetary radar equipment for monitoring the space environment. So being aware of where satellites and space junk and so on are. And the radar is really good for that, particularly at the further out orbits, so things like geostationary and so on, which are not well covered by anything else. And so, yeah, there is a potential market out there, but it isn't. It's not a well-developed commercial market at the moment. So.
Do you have many vibration-related issues in the performance of either the radio or the optical instruments?
Vibration?
Yeah, vibration-related issues.
They had a lot of troubles early on with the cables vibrating. And they're under huge, it's like a violin string or whatever. And so there are a number of weights hung on the cables in strategic places to damp those things out. So I'm not aware of any problems with vibration on the main platform at the moment. And the optical equipment is basically all inside and looks out through windows. So it doesn't have a problem from that. And the stability of the main platform is the vibration. Well, of course, if it were a resonance, it could get quite big. No, I'm not really. We don't really have problems with it. It is damped out.
Thank you.
A couple of observations. One, you need to get PBS NOVA to do a program on Arecibo.
We need the public to tell them they want to see such a thing. We have hosted a number of science programs at Arecibo, but actually those are the things we really like doing, so we'd be delighted to have more of them and delighted to support such things.
The other point would be to emphasize the importance or the basically you wouldn't be able to do what we're doing now without the advances in mathematics and computers, and we're talking about convolution and all, matrix operations and all this stuff, and get people to teach that in the schools, a simplified version, instead of doing, a squared plus b squared, factor this, and till you're out of high school.
Yes. I think, as we were saying before, the problem of education and of bringing people into the sciences, but education in general is a real problem to the Western world, I think, all over this country and Europe also.
The point being, utilizing an existing, real world, something you can see and touch, which really affects young people and fires up imagination. And amongst these is your new generation that will stand in your place, I hope 30 years from now, and give this talk.
Yeah, I'm amazed at what school children visiting Arecibo, and we have a thing called the Saturday Academy that brings in high school students. It's amazing what they can do if you give them the facility and the environment in which to do it. So
Thank you.
So there is something about this that I don't understand. The way I see it, your budget could be funded for the next 10 years by taking Ringwood and 2 blocks on that side and selling it off. I mean, of course, it's not ours to sell or the NSF's to sell, but it's not a lot of money. $12 million a year is not a lot of money. I also realize that we live in a profoundly ignorant time, or in which our so-called leaders don't understand and don't accept some very, very basic things. But that said, I'm wondering, how much of your time are you guys spending trying to get the funding situation done? taken care of? Because to me, if there's no money, there's no science, right? I mean, it doesn't seem that hard. I mean, we are 5 miles away from google.org, right? I mean, we're...
Yes, what you say is true. The amounts of money that we're talking about, compared to almost anything else you can think of, budget of a small school, a mile of freeway or something like that. But that's true across science in general, that the amount of money that is needed to do science is not huge, but it is difficult to come by. So.
On a more technical note, I'm wondering, were you able to correlate any of your observations with gamma ray bursts?
Yes, there's work exactly in that area, but it's not my field and I don't really know enough to talk about it, so I'm sorry. Bob Kerr probably could have done. So.
Thanks.
I'm sorry.
Suppose that one were to put a simple half-wave dipole along that line focus and connect it to a well-constructed crystal set at maybe 20 meters or even the broadcast band. Would you hear anything good?
That depends whether you believe there's anything good being broadcast. It would certainly make a pretty impressive crystal set.
That's what I thought.
In the optical world, they use adaptive optics to improve the performance. I was wondering if there's any similar thing in the radio telescope area that would be improved by adaptive techniques.
Yes, some of the other dishes actually do have adaptive surfaces. Arecibo doesn't, although we actively control where the focus is by moving the platform and twisting the platform.
You don't change the reflector, though.
Yeah, no. But there has been a fair amount of discussion about that multi-feed system that I showed you, of replacing that with the small phased array, and then doing adaptive correction for the dish in that array. I'm not sure that anybody's actually done that yet, but we're talking about it and other people are talking about it too. So.
Thank you.
So Tony, thank you very much for your talk. We have for you the much sought after Cafe Sci coffee mug. We have one for you. So, I just want to add that, SRI certainly feels very strongly about science and math education for students. We have an entire division, in fact, devoted to education research. And we couldn't agree with some of the points of view that have been expressed. We couldn't agree with them more. We'd love to, and we do, in fact, actively encourage science education and the education of our youth. And we also are always working hard every day on trying to get additional government funding for very important research and development work. And so I'd encourage you to make that point of view, share that point of view at the ballot box when you have an opportunity, and don't hesitate to, write to our elected representatives if you believe in science, because we sure do. So thanks for coming, and we hope to see you next month.